And good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Group's main meeting. So we have with us tonight Javier, who's going to talk to us about high availability and disaster recovery in both Azure SQL Database and Azure SQL VMs and managed instances, as well as SQL Server. So please, Javier, take it away.
All right. Thank you, Kevin. Thank you for the invitation today to share in this user group. I believe it's the very first time. So today the idea is to cover a little bit about the basis of high availability and disaster recovery for SQL and Azure SQL environments. Right. The idea is to see from the perspective of how to come up with a project that will have these topics covered, ideally from day one, and see how we can stay up in business, even if we have a major issue within our data center. So let's start with that. If there are any questions, feel free to stop me, put it on the chat window, and we will try to address them as soon as they come up. So start. All right, a little bit about myself. My name is Javier Villegas. I am from Buenos Aires, Argentina, and where I am at right now. I work at a Mediterranean shipping company as IT director in the DBA BI Services area. I've been involved with SQL Server for more than 25 years now. My very first SQL Server version was 6.0, so long time ago and quite difficult to accomplish HADR back then. I am MVP, Microsoft MVP in the data platform category since 2016. I'm also Microsoft certified trainer. I'm also one of the members of the Azure Data Community Advisory Council. I define myself also as a technical speaker. I would like to participate in every meeting, every place in where we're talking about data. I'm also one of the organizers of our local community down here in Buenos Aires, SQL Argentina. We have our own meetup, our community, and it is in Spanish. But if you would like to join us, feel free to do it. We have also our regular meetings. I leave over there my contact information, email, LinkedIn, Twitter, and my blog, in case you would like to get in touch with me. If you have questions about this specific presentation or anything else you would like to discuss, feel free to reach me there. All right, so the idea is to come up with, as I said, high availability and disaster recovery options in SQL and Azure SQL, right? SQL Server, we all know what it is, right? It's the product that we've been installing for many, many years in our own servers or virtual machines, on-premise, in our laptops for development purposes, etc. And then we have this new concept of Azure SQL, right? So the idea is to start a little bit understanding what's the difference between SQL Server and Azure SQL, if there are differences, and then go through to the HA DR solutions, right? So first of all, the Azure SQL family is, I like to call it umbrella, in where it's covering several products and services. One of them is Azure SQL Virtual Machines, which are basically virtual machines deployed in Azure running the very same SQL Server bits that we have in our own laptops, in our own data centers, right? So the only difference is that when we create those virtual machines, well, the installation comes with a set of, let's say, best practices already applied. So it's way easier for us to put it up and running. Besides the whole thing in Azure, which is scalability, right? We also have high availability in certain area, right? Just by having one of these VMs up and running. But then there are other things that we need to consider to be able to stay up and running all the time. Then we have two services in between, right? It's like SQL Server as a service, right? Where we don't have to worry about the infrastructure behind the scenes, right? This is Azure SQL Managed Instance and Azure SQL Database. There are two different services because they are targeted to different kind of workload or scenarios, right? Managed Instance is more targeted to be SQL Server as a service, as we know it, right? And Azure SQL Database is targeted to, let's say, more modern applications, right? Also, when deploying these services through the Azure portal, we have certain high availability and disaster recovery available. But then if this is a mission critical environment, we will see today in this presentation how to enhance it, how to make it more available, right? And then the last component of the Azure SQL umbrella is Azure SQL Edge, which is giving us the possibility of running SQL Server on an ARM device like this, right? This is a Raspberry Pi, right? Which is an ARM device, so we can run SQL Server in here, right? Of course, this is not for our mission critical decision-making workload, but for certain scenarios at edge, like collecting information as from sensors, processing and storing it is really great. We won't be covering the high availability and disaster recovery for this device today, but we will be covering the other three components of Azure SQL. Right? So today, SQL Server is, like Microsoft like to say, it's from edge to cloud, meaning that we can run it on almost anywhere, right, or everywhere, right? Edge with this ARM device, SQL Server, in where we know that since 2017 we can run it also in Linux platform. Over there are also a lot of techniques to enhance high availability and disaster recovery. And then, as we quickly saw before, running the PaaS offering, right? The platform as a services, managed instance, and Azure SQL Data. So let's start digging a little bit on what high availability is, right? So the definition for high availability is the possibility of any system to operate continuously without any failure on a specific period of time, right? So this way we can make sure that no matter what happens, right, our system keeps up and running. We know that there are certain scenarios in where not only our SQL Server, our whole system have to be up and running all the time, right? We know that 100% of the time is impossible, right? Because there's gonna be certain things that we may need to do on purpose or not, right? That may disrupt the availability. So it's impossible to have 100% availability of our system. So the way that we measure this availability is with nines, right? So that is why we said 99.9999, whatever amount of nines we would like to accomplish for our system, right? So the goal is, again, being able to design our environment, in this case, SQL Server, right? To be available almost all the time, right? And we would like to see what is necessary to accomplish this. In my own experience, right, being able to design one SQL Server environment, having high availability and disaster recovery in mind from day one, meaning while we are working on designing the environment for our project, is key to make this succeed, right? Because, you know, if someone comes to us and say, hey, I have this standalone SQL Server running, and I would like to add additional high availability and disaster recovery or additional nines to our HA measure, right? I'm not saying it's going to be impossible, but it's going to be a little bit more difficult than having the whole environment up and running from day one. There are also some other, let's say, things to consider. I would say that if we would like to accomplish as many nines as possible, right, meaning high availability as much as we can, that will cost a lot of money, because we will see that one of the principles of the high availability and disaster recovery is redundancy of certain components, right? That means we may need to buy certain things that in some cases they will be in kind of standby mode, just waiting to get into action in case of something happened to the main component, right? Or, you know, just being able to replace the activity as quickly as possible. That will cost certain amount of money, right? So one of the things that, well, nowadays, I would say that everybody is kind of aware that we may need this in order to have, you know, a critical environment up and running. But I do remember many years ago in where convincing, you know, the management of the different companies, right, say, hey, we need to accomplish HADR, and for that we have to buy this, and this, and it's going to cost us 3 more times that maybe buying one standalone environment, right? And the question used to be, hey, are we going to be operating 3 times faster, right? And the answer is no, and it still is no, right? Because this is not to buy stuff to make the environment faster, right? It's buying the components to make the environment more available, right? And in case of a problem, being able to continue our operation, right? Now today, this discussion, I believe, is over, right? Everybody can understand that having our environment down for a certain amount of time because of a failure, because of maintenance, or any reason, right, is going to cost the company a lot of money, and, you know, not only money, right? So this is, as I said, a situation that today is a little bit more easier than what it used to be, right? So definitely, you know, if we would like to consider building our environment to be almost or close to 100% available, as I said, we need to design it to avoid what is called single point of failure, right? So this is extremely important to, first of all, understand in our environment where the point of failure could be, right? And being able to have a solution, right, to address if that component has a failure. For example, let's go from the easiest one, right? If our SQL Server has only one disk, right? What happens if that disk fails, right? Well, there are techniques in where we can have multiple disks in some sort of mirroring, replicating the data internally. If something happened with one of them, we can remove that disk put another one, and nobody realized. That's good, and let's say that's the simplest example. But what about if the whole enclosure for the disk has a problem? Do we need to have another enclosure with another set of disks? Well, those are the things that we need to start asking ourselves, right? Is our business going to support that particular point of failure? The servers may need to have two network cards to connect to the network itself and also to connect to the storage, right? If one of the channels goes down, we always have the redundancy within the other channel. And there are many, many other components, right? Including not only our servers, also at networking level, right? We may need to have duplicate switches, right? In case of one of them goes down. And then we have the other the other thing. What if our server goes completely down? And I've seen this many, many times, right? Let's say one of the servers, one of the VMs just crashed, and we are not able to restart it, right? What do we do? Okay, for those cases, we may need to have a server in kind of standby mode there, right? In case something happens with the primary. And what we will see later today is how we can have our SQL Server environment prepare for those kind of situations, right? If the whole server goes down in where we, let's say, need to have some sort of copy in a standby mode, which are the techniques that we can use to address that situation, right? If one of the disks go down, if one of the network counts go down, well, that can be solved through, besides having the component, right? The hardware will take care of addressing those problems by themselves. But as I said, there are multiple cases in where the whole server can go down, the operating system not responding, you name it, right? So definitely, if we want to accomplish HA, meaning high availability, we need to make sure that we know how to measure it, right? As I said, there are, the most important thing, as I said, is this availability number, right? That we call SLA, Service Level Agreement, which is, the number of nines that we can have in our environment. We will go through that in the next slide, right? But there are also some other metrics that are important for us to understand our environment and to address high availability, right? And definitely knowing all these things and have it properly documented will help us a lot in eventually predict when the next failure could happen, right? So those points are mean time between failures, MTBF, right? So that is the expected time between two failures. Let's say today we have a failure on a network card. In 6 months, we have a problem with a disk, right? We have to document that, and we may need, right, we may have to document this information. The failure could be, also not being able to deliver SQL, right? Meaning that there was an interruption. So this is important to have it well documented, right? Mean downtime, MDT, right, is the average time that the system is not operational at all. You name it, why, right? But that could be certain amount of minutes, hours, days, and again, knowing this value is also important to understand our environment and work to try to avoid having downtime, right? And make sure that if we have, those are pretty short, right? RTO, recovery time objective, is that what's gonna be the amount of time, minutes, hour, whatever, right, of for us to repair or to solve the problem, right, of outage, intentional or schedule, right? So it's also important to know this value so we can have all this together, build our documentation, and as I said before, eventually predict when it could happen again. We also need to consider some other things, right, in terms of availability. There are certain updates that we need to apply at the OS level and at SQL level, right? So, this is not happening every day, and maybe we don't need to apply all of them as they come up, right? But definitely having our environment up to date is important. We all know that. We also know that applying these updates, these patches, will take our system down for a certain amount of time, right? Knowing this and also be prepared for this is extremely important. We also have seen environments in where we try to apply a patch and the patch breaks the whole thing, right? So what do we do in that case? Do we try to revert? Do we try to do this concept of failover, right? Remember this word failover because we're going to be using it a lot, right? So knowing this, knowing how to measure HA will help us a lot. So service level agreement and these, nines that we were talking about at the beginning, right? So as I said, is the percentage of the availability for our environment. And just to give you some information regarding to, right? What does each of these nines mean? So if we say that the SLA for our environment has 3 nines, right, meaning 99.9, that is 8 hours, 45 minutes, almost 46 minutes per year, right, in where our system is allowed to be non-operational, right? If we have 4 nines, 99.9, right, that number gets reduced to 52 minutes and a half, right? Imagine your environment having to be, or being able to be down only for 52 minutes and a half. And if we, keep increasing the number of nines, we can go to up to 3 seconds of non-availability per year, right? And believe me, there are certain environments that this happens, right? So knowing this is also important because we can, let's say, build our environment from day one, considering this, right? Say, okay, let's build an environment that needs to have an SLA of 4 nines, right? So with that, it's not like we go to the vendor and we say, hey, I need this component to have 4 nines of SLA. No, but we need to definitely have this number in mind when we're building the environment. So how to achieve HA? First of all, design the environment having HA in mind from day one, right? Extremely important, and that will solve much of the problem. Test the HA solution. That means that when we have the chance, not relying on or just think, oh, I have everything duplicated. I even have a secondary server in standby mode. So the day that we have a problem, that's going to work. Well, believe me, it's important to test it when we have the opportunity. And actually, there are certain ISO certification that if we would like to accomplish at the company level, we need to do a test, right? what I said before, the failover test once or twice a year, right? Just to make sure that if we have a real scenario where we are in troubles, our system is prepared and we know by fact that it's going to work. Right? Also important to monitor the whole solution, right? We can say, hey, I know that my system has 3 drives, right? But if those 3 drives that in theory are replicating are degraded because there are only 1 working and we don't know that the others are not, well, guess what? If we have a problem with the third disk, we just thought that we have the whole thing up and running, but instead it's not. So definitely monitor the whole thing and document every single activity that we may know as a failure will help us in having HA available in our system. So let's say we buy 2 servers, state-of-the-art, multiple switches, network cables, everything, right? What if there is a natural disaster that destroy the data center, right? Or what's going to happen if the whole city power system goes down, right? What if there is an earthquake, right? Doesn't matter how many systems we have within the same data center. If we are not able to power up those environments, the whole system will be down, right? So we won't have availability. If the cooling system is not working, right? Again, doesn't matter how many servers we have or how many disks, right? We're going to have a real problem. And if there is an earthquake, right, the whole system will also be unreachable. In my professional experience, I've been into 2 different situations related to earthquake, right? In Chile and New Zealand, in where we have HADR in place, so easily we were able to recover and not we haven't lost a single bit of information in there, right? Because we had the HADR solution in place since day 1, right? So what do we need to do for this? Okay, first of all, get another data center in a remote location, right? In where we can replicate the whole environment. What does it mean? I've seen cases in where I am told, yeah, we have a duplicate data center. Is 2 floors back or 2 floors down in the same building or across the street. But it's not ideal. Right? It's not even close to the ideal. What we should do is come up with a different data center on a remote location, right, in a different state, in a different country, in a different province, in where, if eventually something happened to the main system, right, we are able to come up and running without, being able to deliver the service, right? How do we do that? Well, first of all, we may need eventually a server, right, with the whole, infrastructure around networking, disk, etc. And in terms of sizing that environment, well, ideally that should be same as the primary servers are, right? Because if let's say we dimension a server that is way smaller than the one that is acting on the primary data center at the read-write copy, right? And then eventually we have to support the business with a server which is 1/10 of the size of the original one. we won't lose the data, right? That is great, right? But if we don't have the horsepower to support this, well, we also gonna be in trouble, right? So the idea is to see how we can set up our SQL Server environment, in this case, up to now, on-premise, right? Which are the SQL Server techniques that we may have to accomplish this, and then which are the additional capabilities in terms of HADR that Azure provide us for our SQL Server virtual machines, as well as for managed instance and Azure SQL Data, right? Something important to mention, right? It is, I would say that one of the things that I'm told is, oh, we have an HADR best practice in place, which is backup and restore. That's good, right? But I would say that should be the basis of every single SQL Server production mission critical environment, right? That is not for HADR purposes, right? But definitely one of the high availability disaster recovery approaches could be, I don't care how long our system is down, as long as I can recover our databases and not losing any data, right? That is a possibility, right? So for any of these scenarios, we definitely need to make sure that our backup solution is in place, right? And also being able to test those backups, right? I've seen multiple scenarios in where maybe the DBA is telling us, oh, yeah, we have backups, but the day that we have to go and reach those backups, we can access them, we can read it because they are corrupted or anything, right? So definitely taking the backups and test those backups by restoring them, definitely important to consider. So let's go to some SQL Server techniques that will help us to, let's say, have a copy of our data in a different environment for HA purposes, meaning within the same data center. So in case something happens right away, being able to switch to this other environment almost online, right, and continue serving the application. Or if the whole data centers go down, right, and we need to switch to a different data center, right? Let's see those techniques, right? Some of them are not initially targeted to be HADR, but they can be used, right? So we will go through many of them, and then we will see which one is best and which one we should use, right? One of them is SQL Server replication, right? This one will help us to replicate certain tables from certain databases. There are certain things that we need to make sure, right? The tables need to have certain structure, primary keys, etc., right? And again, this technique is mostly to replicate data for business purposes. But again, at the end of the day, may accomplish what we need, which is having the data on a different location in case something goes wrong to our primary environment. So in the pros columns, right, we can say that eventually we can replicate to multiple servers, right? So this is something quite interesting, right? And in the cons is like, if we need to do a failover, right? Remember, doing a failover means that switching the role from the replica or the server that is the read-write copy to the one that is in standby mode, right? If we need to do a failover, it has to be manual. That means that if the problem happens in the middle of the night, someone will need to perform the failover manually, right? It's going to take a long time to do the setup if the databases are big, right? And definitely troubleshooting SQL replication historically has been an issue, right? Then Microsoft came with another approach, right, which was kind of interesting, right, which was called database mirroring, that today is discontinued, right, and then we will see what has replaced database mirroring. But back then was a really interesting solution because, the setup was quite easy, right? The failover process was also fast and eventually could be automatically, right? If we configure the environment, if there is a problem on the primary replica, automatically we can switch the role to the server that is in standby mode. So quite interesting, right? And it can synchronize or replicate the whole database, right? Not table by table. So on the whole database. Really, really good, right? There were some cons, right? Is that it is limited up to 2 servers. So this is for availability only, not for disaster recovery. Actually, it's for one or the other, right? And this replica that is the secondary or the one that is in standby mode cannot be accessed. It's just in standby mode. Nobody can use it up to we need to put it online, right? This database mirroring feature, which, as I said, was widely used and widely accepted back then, was replaced by another great feature, which is called high availability groups or always on, right? In SQL Server 2012, which today in SQL Server 2019 and also in 2022 is the main feature to accomplish HA and DR, right? So we will go through that in a minute. Then there are other ways, which is, one of the initial, let's say, way to accomplish high availability and disaster recovery was log shipping, right? This is mainly based on the fact of doing backups and transaction log backups and applying those transaction log backups continuously, right, to our secondary environment. So in case we had a problem, we can use that one. Again, a lot of pros and cons, right? The main pro is that, again, same as SQL Server replication, we can ship those logs to multiple servers, right? Eventually, the secondary databases can be accessed in some sort of read-only mode, so we don't use it only for HADR purposes. We can also use it to do to offload our read-only workload, right? Quite interesting as well, right? And another big pro is that does not require enterprise edition licensing, right? That in some cases we know is quite expensive, right? Again, manual failover. So if we need to switch the role, we have to do it manually, and the maintenance or the troubleshooting is kind of complex, right? All right. So then, if we start digging a little bit more, there is another technology which is actually not from SQL Server. It's more from the OS standpoint, right? Which is failover clustering, right? The concept of failover clustering is mainly that we have 2 or more servers or virtual machines, right, that are sharing the same storage, the same disk. So there is a way to install SQL Server from the installer, and when you set up a SQL Server failover cluster. So you set up the first node, right? And then there is a different installation type for the other nodes, right? The terms are active and passive node. What is the difference between one or the other? Where active node is the one that is owning the disk at that specific time. Passive node is the one that is up without owning the disk, but just waiting if something happened, right, to become the new active in a matter of seconds, right? So that means that we install SQL Server in all the nodes, right? But only one of them is accessing the disk. So the data files, the log files, and everything. And if there is a problem with the first node, right, we just do this failover, which is switching the roles, right? So eventually we can switch the roles from one point to the other, right, in a matter of seconds. You can ask me, that's good. We have 2 virtual machines. What do we need to do with the connectivity, with the clients, with the application that are trying to connect to this cluster? Well, when we set up the SQL Server failover cluster, we're going to come up with a virtual name and a virtual IP address, right? So it doesn't matter which node within the shared storage failover cluster is the owner, the clients will always connect to that virtual name and virtual IP address. So we won't be connecting to VM01 or VM02. We will be connecting to the SQL Server failover cluster virtual name, right? So doesn't matter which is the owner, right? We always be having SQL Server. So if something happened to our active node, automatically the SQL Server process will start doing the failover, and in a matter of seconds, right, we will have the environment up and running again. This is also quite interesting if we need to apply a patch at the OS or a SQL Server point of view, right? And why I'm saying that, if we have only one server, we know that installing the patches will disrupt the service. Rebooting the environment could take several minutes up until it's back online, and that's a long time in where our SQL Server will not be serving, right? And that is no availability. If we have a shared storage failover cluster in place, what we can do is we can go to the passive node, apply all the patches we need at Windows level and SQL level, reboot the passive node as many times as we want or as we need until it's fully patched without disrupting the service, right? And when the passive node is fully patched, we initiate the failover process. That means that when the failover is complete, right, SQL Server and the OS will be fully patched in the new active node, right? This is also an interesting approach when we are upgrading the SQL Server version, let's say from 2016 to 2019, right? We go to the passive node, we do the upgrade there, we get it ready with all the patches and etc. We reboot it as many times as we want, and then we do a failover. And this process of doing a failover is a matter of few seconds, right? So the availability will be way, way higher than if we have only one virtual machine, right? So shared storage failover cluster is available since SQL Server 6.5, 7, NT4, right? Windows NT4, so from a long time ago, right? So again, it's a Windows feature, but SQL Server can take a good advantage. In Azure Virtual Machines, right, we have many types of storage, right? Premium, standard, ultra, right? Until 3 years ago, we had very good storage in Azure, but we didn't have the possibility of having having it as a shared storage. So meaning 2 or more virtual machines sharing the disk. So we didn't have the possibility of using this specific setup in Azure, right? So how do we handle one of these shared storage failover clusters, right? We can have, 2 or more nodes, as I said, right? So those are the cluster nodes. Then we will see the roles, and in the roles we see SQL Server. So we see all the shared drives. Then we see also the virtual name and the virtual IP address, right? And then the SQL Server services. And finally, we have all the available storage, right, as shared. So this is shared storage failover cluster. Then we have the feature that we mentioned earlier, which is always on or availability groups, right? This is also based on the window cluster services, right? But we can have it without sharing the storage. That means that we can have one server, one standalone VM with is dedicated to storage, right? And then we can have another VM with its dedicated storage. And if we enable availability groups, we can have one or more databases, right? Synchronizing to all the nodes, right? That means that we can have our availability group, one or more, right? Distributed across 2 or more instances, right? In where only one of them will be the primary, right? Meaning the read-write replica, in where everybody will do insert, update, delete, of course, select if it is needed. And then we can have several secondary replicas, right? These secondary replicas, if we want to, we can configure them to be read-only, right? So if we do an insert, update, or delete in our primary replica, right, we will see the data updated in our secondary replicas. That means that if we configure to be read-only, we can use that replica as a source of, a data warehouse, reporting services, or whatever we need, right? And this way we offload certain heavy workload, which is going to be only select, right? Because again, on the secondary replicas, we cannot do update, insert, or delete, right? But we can have it. And eventually, this node can be located within the same data center, right? Or on a different data center. And this way, we can have, a network connectivity with a data center which is remote on a different location. And over there, we just, replicate our databases. And eventually, if we have a DR situation in where our main data center goes down, we will have the replica up and running. And if we have the whole networking configured properly, we can also go to that replica, right? So in terms of the always on availability group, there are certain things to be aware of, right? And there are the modes. First of all, we have 2 modes, asynchronous or synchronous mode, right? Let's talk a little bit about synchronous first. So if you have an availability group with 2 replicas, 1 database, let's say, you will be always connecting to a virtual name and IP. We're going to go there in a second, right? But if the replica or the HA, the availability group, is configured as synchronous commit mode, right? If you start a transaction, right, it has to commit on both replicas, right, to then finally get the acknowledge to the client, right? That means that the network connectivity between the 2 replicas should be really fast, right? So This way, SQL Server is making sure that the data is exactly the same on both replicas, and there is no data loss at all, right? Just making sure that is synchronously committing on every replica, right? This is a good scenario to accomplish high availability, because we know that we can have within the same high-speed network multiple replicas with its own storage in where it will be synchronizing, and we're going to be 100% sure that there's not going to be data loss. Then we have the asynchronous commit mode, right? Which basically, when you start a transaction, it's going to commit only on the primary, right? And it's going to make the acknowledge to the client, right? And then in some sort of a background mode, it will be synchronizing to the asynchronous replica, right? In this case, right, we can have eventually data loss, right? Because it's an asynchronous process, right? But, if you have, the synchronous mode requires, of course, a high-speed network, but the asynchronous mode, it cannot, right? So it's a good fit, and actually it's the best practice when you are replicating to a remote location in where the network connectivity is not super high, right? So you have to make sure that there's going to be some data loss. Of course, there are many ways to monitor this and eventually tweak the whole system to make sure that this asynchronous thing is not making our secondary replicas to be way out of sync and just a matter of few seconds, right? But this is also important to know in advance. So then we can have a couple of types of failover, right? One of them is automatic, right? So it's not going to be any data loss. And again, same of the shared storage failover cluster. If our primary replica goes down, it will go to the other replica automatically right away in few seconds, right? But in order to have the environment ready for automatic failover, that secondary replica must be configured in synchronous commit mode, right? Then the other mode is manual, right? In where we can have some data loss eventually, right? But if before doing the failover, we make sure that the data is fully synchronized, and there are certain techniques we can have no data loss also. For the connectivity, the client connectivity, again, we're going to have this concept of virtual name and IP address, right? Which is called listener, right? So the listener will always have always the same name and IP address, but internally will be pointing to the replica that is the primary, right? Always in a availability group, there's going to be only one primary. Going back to the synchronous and asynchronous commit mode, within the same availability group, you can have some replicas configured in synchronous mode and some others in asynchronous mode. So this way, again, you can accomplish HADR, as we mentioned at the beginning. This is the feature that is definitely the one that everybody uses in order to set up high availability and disaster recovery. Of course, you can combine shared storage failover cluster, right, to be one of the instances, right, with availability group, right? That is another layer of availability that you can have for your environment. So how do you see it from Management Studio? Well, you can see it as availability groups with the multiple replicas here, the multiple databases that you can have within the availability group, and this concept of listener. This is going to be the name in where all the clients will be connecting to, right? So quite interesting. Very good. So if we start digging a little bit more within Azure, right, we know that Azure is basically a data center which is deployed in around the globe, right? Not only one data center, actually many data centers, where Microsoft calls them as regions, right? There are at this moment more than 60 regions around the globe, right? So if we set up one of these virtual machines, right, just by deploying it, right, we have these two ways of doing this in order to accomplish high availability, right? We can have availability set, right, in where Microsoft assures us that we can have 99.95% of SLA just by having one VM, right? And then we have this concept of availability zones, right, in where we can have 99.99%, right? Not only just by deploying one VM, just deploying many of them, right? Let's say one replica in one of these modules and the other in the other one. And I will explain a little bit how it is, right? In the availability set mode, they have what they call update domains or fault domain, right? In where, you know, Microsoft has to do their own updates to the infrastructure behind the scene to support our virtual machines and everything, right? So there are different update domain or fault domain in where Microsoft is telling us that if you have your VMs deployed into multiple update domains, they will never do maintenance at the same time in more than one fault domain. So when they're finished with one of those, they will switch to the other, but never concurrently. This way, we can distribute our VMs into multiple update domains and make sure that it's not going to be impacted by anything, right? Then in terms of availability zone, right, each of these given Azure regions, right, can have up to 3 availability zones, right? Availability zones are actually buildings, data centers within the same region, but they have different power source, different cooling, different everything, right? And they are connected with high-speed networking, right? So eventually, if there is a problem in one of these availability zone, we can have another replica in a different availability zone, and we won't be impacted, right? So then again, in terms of HADR technologies, right? As we were covering some of them, we will have, you know, many, and we can even combine them, right? In Azure, there is another one specifically, which is called Azure Site Recovery, right? Where there is a process that basically will be taking a snapshot of the virtual machines, right? And if we have a problem, let's say that the VM crash, or there is an availability problem within the whole zone, right, or region, we can restore that snapshot, right, on a different location, right? And we won't lose our data. But, right, this is not a continuous process. So there are certain snapshots through the day, like I believe that 4 times a day. So we can have potentially an important data lost if you know, the snapshot was taken 4 hours ago, let's say. And actually, this solution is not ideal for SQL Server, because you know that when you have your SQL Server up and running, certain data is at this level, and other data is memory, right? So when you take the snapshots, you won't have everything you need. And potentially you can even have data loss and data corruption, right? So the best practices for accomplish HADR in SQL or Azure SQL Virtual Machine is actually high availability groups. So then here, I have other description in terms of this, etc. But I would like to go through the future, what is coming, right? Microsoft has announced SQL Server 2022, right? Which is right now in release candidate 0. So we can all download it, test it, and it has a bunch of features, right? But one of the really interesting feature that we have is the possibility of combining SQL Server, virtual machines, or servers running on premise, right? Within the same availability group of what is called distribute availability group, and having secondaries on managed instance, right? That means that our primary environment, the read-write replica, would be on-premise running SQL Server 2022, and we will have an asynchronous replica in a managed instance, right? That, again, we can use it as a source of read-only workload, and eventually, if we have a problem with our server, we can switch the role and do the failover, and the read-write replica will be the managed instance, right? And the secondary replica will be the SQL Server 2022. So we can, do this failover if we need it, right? So really, really interesting. Another important new feature within SQL Server 2022, and something that I haven't mentioned until now, is that, as I said, availability group is the feature to do HADR, right? But this is only to synchronize or replicate user databases, right? Your, let's say, system objects, like, for example, logins and SQL shops, for example, are not replicated through the different instances today, right? If you create a new login at the primary, or if you change the password of an existing login at the primary, or if you create a new SQL shop, that is not going to be replicated or synchronized to the replicas, right? You have to do that manually today, right? There are a lot of tools that help you to do that. For example, DBA tools has a great possibility to do this synchronization, but again, it's something that you have to do manually, right? Well, in SQL Server 2022, there is a new feature called contain availability group, in where you're going to be able to not only synchronize your databases as you do today, right? But also synchronize the logins and the SQL shop, right?
There's a question that came in from chat here.
Yeah.
That SQL Server 22 instance that you showed in the prior slide, is that on-premises or Azure VM or both?
Both. You choose, right? There are, certain, let's say, prerequisites in terms of networking, right? Which are not different to the ones that you have today. You have to have connectivity within a certain TCP port, but if you are able to accomplish that, then you can have your SQL Server 2022, right, running on-premise in your own data center, and have Azure SQL Managed Instance in Azure, of course, in any region, and have this asynchronous, right, synchronization. So doesn't matter if it is a VM or if it is SQL Server 2022. on-premise. I hope that answers the question. And I will add another thing at the top of it, right? Which is not totally HADR, but it's also something that is important to mention in this case. You can have from SQL Server 2016, 17, and 19, you can do the same. You can have the SQL Server, your user databases on-prem or in an Azure VM, and you can have a read-only replica or copy in a managed instance. The only difference between 16, 17, and 19 with what is coming with SQL Server 2022 is that you're not going to be able to do failover to switch the roles, right? You can only do the failover and the failback if you have SQL Server 2022, right? But if you have 16, 17, or 19, you can have your replica in Azure to offload just the read-only workload. Right? It's quite interesting, right? It's not DR purpose. Eventually, you can consider that you have your data replicated in a different location, but you're not going to be able to use it or to do a failover if it's needed. But your data is covered. Right? You won't lose data at all. Mm-hmm. All right. So for the demo, right? Let me tell you that I have here a video that I record from my environment that luckily I had my video because my VM crashes a few days ago, right? When I was checking the whole thing, I was not able to access my virtual machines. I believe that there was a problem with my Azure subscription, right? But I have their recording, and I will play the video and explain what I was doing here. Basically, the idea is to, where is it? Here. So let me just go there. Here, what I have basically is two virtual machines in Azure, right? And I have an availability group already created, my HA2, in where I have VM1 and VM2 and one database already in the availability group. When I switch to the other replica, VM02, I have the same information from Management Studio, but now it's saying that is the second, right? So we will create a new database, right? My new demo DB. A prerequisite is the database must be in full recovery model, right? To be part of the availability group. I haven't mentioned that. And we need to have a full backup. So if we have that prerequisite there, we just go to Management Studio on the primary, we just add database. The wizard will give us everything. Actually, it is saying that the test database is already part of the availability group, right? And the new database that we should create, it meets the prerequisites. So we go next. The wizard will connect to all the secondary replicas, if there are more than one, right? And then it will do the seeding. The seeding is to do the whole setup for us. There are multiple ways of doing it. The easiest one is do the automatic seeding that will take care of everything, right? Of doing the backup in background and having our database up and running. If we go to Management Studio and we refresh it, now we see that we have the database with the keyword synchronized. So it's part of the availability group now. If we go to the other node, right, we see that without doing anything on the secondary node, we have this new database within the availability group, right? Just remember that we create a brand new database which was empty. So now what we will do is we will create a table called demo table, right? In where I just put some random data from the sysoption. So we have certain amount of rows there. On the replica, right, I just do the same, but I see that I have my table over there, right? On the primary, I can delete certain rows, right? Let's say I'm deleting the object ID smaller than 100. So now, we see that we have less amount of rows. If I go to the secondary and I try to do the very same deletion, right? Guess what's going to happen? Right? Here, I'm showing that I have exactly the same thing. But if I try to delete from the secondary, I will get an ugly message saying that I cannot update anything because it's a read-only replica. Doesn't matter if I am the sysadmin on the replica, right? That you can only do select, right? So this is important to mention. And then eventually, let's say that I need to failover, meaning I want this replica 01 to be secondary and 02 to be the primary. This is configured to be synchronous, so I'm getting my green checker there, and no data loss. It's going to connect to all the replicas here, and boom, the wizard will do everything for us. And in a matter of few seconds, the other virtual machine is the new primary, right? The 02 is the new primary, right? So you see that now 01 is secondary. Right? Again, if we want to delete here now in 01, before we were able to delete, now we can't because it's secondary, right? And if I go to the other VM, I just do a refresh to see that now is primary, and eventually we can delete, update, insert, or anything. All right. So we can have, I believe, up to 16 replicas within the same availability group. We can have multiple availability groups within the same instances, right? In where we can combine which is primary and which node, right? And with that, we can tune our, let's say, high availability and disaster recovery environment. Again, it's important to have this cover and design from the very first minute, right? So knowing that it's going to be way, way easier to set up. Let me go back here. All right. Basically, here I'm just sharing the Azure SQL Fundamentals training, in where you're going to have everything related to Azure SQL, including the HA VR capabilities, right? For managed instance or Azure SQL Database, there are easiest way to accomplish higher HA by having synchronizations or replica. It's a matter of a few clicks. For virtual machines, it's quite similar to what we saw on premise and with the samples that I gave, right? And also we can have what is called sheer replication. So eventually, for us, without doing anything, we can have a managed instance in one Azure region while we have another one in a different Azure region, right? And we have it covered, replicated. So if it goes down completely, if the region goes down completely, we are fully covered. And with that, we finish the presentation. Thank you, everybody, for attending today. I don't know if there are more questions in the chat. Kevin?
So if you do have any questions, let's get them in chat. We've got one comment here. Excellent job. And I agree. That was a really great overview of various options.
It's, it's quite interesting. And again, the times today with Azure is way easier than what it used to be on-prem. And again, the most complex part used to be convincing our bosses that we need to invest, not waste money in HA DR. Right?
Oh, that's true.
So
What do you mean the servers aren't being used? Why am I paying for those servers then?
And another problem we used to have is, we have a spare server there that is acting as disaster recovery. Let's use it for something else. So take it, and we lost one leg of the environment. Right? So yeah. I mean, common thing, but again, I believe that now the culture has changed a lot. Everybody understands what being out of business for 1 hour, few hours means, and that's going to cost way more than an additional virtual machine or an additional server, right? So, and reputation, right? That's another important thing that you don't buy with money.
Very true. So it looks like no more questions in chat. So I think let's take this opportunity and wrap things up for the evening. Thank you, everybody, for coming by. Remember that next week we have our business intelligence and data science meeting, and also an episode of Shop Talk. And with that, until we see each other again, everyone, take care.
Bye.